So this is the next example. This one a little bit different from previous example, right? Because the top here is kind of, we can simplify, and the bottom we can simplify also. Okay, before we can find asymptote, in this case, we can simplify it first. So we do it this way. Factor it, right? So this become x, and this is 3 and 1, this minus plus. Okay, so when we have this one, or the top one, we can factor it also. We can do right away, correct? This one, right, you can factor become x, x 3 and 3 here, 1 minus 1 plus. Okay, so from this one, you can see we can eliminate this one, right? Cancel it out. So what we left x plus 3 here over x plus 1. Okay, so in this case, actually in this case, the x shouldn't be 3, right? If 3, this one gonna be undefined. So after we eliminate, we have x plus 3 and x plus 1. Next, we can find vertical asymptote. Okay, from this one, we get right away vertical asymptote become vertical we get from the denominator right here. So from this one, denominator, we have x plus 1 here, right? You let this one equal to 0. So x equal to -1. So vertical asymptote means equal to x equal to -1. That's a vertical asymptote. Okay. So now after this, we can find a horizontal asymptote. Become what? See this one x, right? Power 1, and this one x power 1 also. So you just do like this, kind of x over x, you cut, right? So equal to 1. So this one mean y. So we get horizontal asymptote y equal to 1. Okay. After this one, next one we find x-intercept. Okay, next one we find x-intercept. X-intercept means y equal to 0. Okay, so then replace, this is a y, right? F of x a y. So you can replace in this one, or the original function is okay. Okay, so you replace on here, right? It's maybe much easier. So y becomes 0 equal to x plus 3 over x plus 1. So this one become cross multiplication. So this side going to be 0 equal to x plus 3. Then x equal to -3. So we got x to -3. That means we get the x-intercept coordinate point become, the intercept going to be x -3, y becomes 0 here. So you got this one. Now go to get y-intercept. Y-intercept means x equal to 0. Okay, again, replace in this function, or this one, up to you. So become y equal to, replace every term of x becomes 0. Okay, so I replace on here. So x is 0 plus 3 over x is 0 plus 1. So equal to 3. So then y-intercept, we got this one y-intercept in the order pair, but lay down, x becomes 0, lay down here. And y equal to 3 here, so we come here. So we got y-intercept at x equals to 0, y 3, and x-intercept is x negative 3 and y 0. Okay. Okay, now we start to plot graph. We start to plot graph here. We plot this one vertical asymptote x equal to 1 here. Okay, x equal to 1. Vertical asymptote or negative 1, sorry. This one negative 1. Okay, we start to plot vertical asymptote negative 1, right? Negative 1 should be somewhere here and write down. Okay, but this one have to be broken line, right? So draw broken line here. This one vertical asymptote, this is x equal to negative 1. And what else? Okay, next, and we plot this one negative 1, okay? And then we plot horizontal asymptote y equal to 1. Y equal to 1 here. So 1 may be here. So we draw the line. Okay. So this one is y horizontal asymptote y equal to 1. Then this one should be again broken line. So like that, dash on. And this one is a 1. This one 0. Okay. This side gonna be 1. Okay. When we have vertical asymptote, horizontal asymptote, now we plot for the x-intercept and y-intercept. X-intercept, this one, right? Negative 3 to 3, maybe assume right here, negative 3. Negative 3, y 0, so at this point, this is the x-intercept. Okay, now find y-intercept is x0, y3, x0, y3, so go up here, 2, 3, maybe here. Okay, so we have y-intercept here and x-intercept. Now we consider now how to gonna plot graph, right? Then you see this vertical asymptote, they cut with the horizontal asymptote. So the picture or the graph should be this section or below down here, right? So the picture should be somehow like this, right? And we know this one is the intercept. Right now we have only one x-intercept, so it's right here, right? I mean, sorry, y-intercept. So the graph should be like this, correct? Either like this one, right? Right? But I know it should be on the top because I have y-intercept here. So this one is doesn't write. So we can eliminate it. That's how to consider where the graph gonna be, okay? So now we know now should be on the top above of x-axis and have to be approach to vertical asymptote and horizontal asymptote. So in this case, gonna be like this one. Intercept here, right? Approach closer to horizontal asymptote, and this side gonna get closer to vertical asymptote. And this is a y-intercept right here. Okay, it's a 3, okay, this one 3. So now we on the right hand side we got picture here already. Then you see to the left right hand side here, horizontal asymptote, vertical asymptote. So the graph should be the graph should be this side, right? Or either down here, approach to vertical asymptote, the horizontal asymptote and vertical asymptote. But we know we have the x-intercept here. So now we don't need, this question really easy. We doesn't need to plot any the additional point. We don't need to test because we have this point, right? So we get it right away. This side, the graph should be like this one, approach, right? Approach to vertical asymptote this side, and this one approach to vertical asymptote. Should be a curve, okay? Okay, like this one. But they now come back to this one, really important right here. Because this one we cancel, we cut x minus 3 and x minus 3 top and the bottom, right? Once you cut this one you will learn in calculus in detail later. But now you cancel. Once you cancel this point, when you plot graph pass to whatever here, because we have x negative 3, so you just count to be like equal to 0 and x equal to 3. So that means when you plot graph, plot graph, right? When the pass any x equal to 3, that's when have to be open dot. Now you see this one. This one's a negative 1, right? 2 maybe here, 3 probably here. So in this case, you see x equal to 3, right? The one we cancel it out. This part, when x equal to 3, whatever this graph here, this point should be open dot. You must like the open dot. Okay, this is really important. Okay. Any value when you cut it out, when you plot graph, if they pass through the point, right? Like this one have to be open dot. That means this graph gonna be like a discontinuous function. Okay, you will learn later for limit in the calculus. So I think that's all the one I want to say, because this part is additional. It's important point. It's different from previous example. Okay, concerned about when you factor and you can eliminate that point. When you pass the point have to be open dot, because you already remove, you cancel, so you have to open dot. Sometimes we call void. Okay, sometimes we call open dot or empty whatever point. Okay, so I think that's all for the example. Oh no, how about domain? Domain do the same way, correct? Domain. Still real number, correct? Domain. Domain is what? Every, just say all real numbers. Okay, all real numbers. Except what? Except x equal to -1. What else? That's all. Okay, only this one, x, except x for the domain. Okay, that's for the value of domain. Okay, so I think that's all for example. I will leave it right here and see you're gonna practice for the question. Okay, I think that's all for this section. See you next class. Bye.